property managers receive maintenance requests as frantic, unstructured text messages. A tenant texts, "Water is everywhere under my sink. Help." To automate a dispatch, we need that panic converted into structured JSON data. Today, we are building a Node.js webhook, a smart maintenance dispatcher, to automate that exact conversion. This system uses the Meta Model API and the Muse Spark 1.1 reasoning model to process the raw text and output a reliable JSON structure. Before a system can automatically assign a plumber, it first needs to translate human panic into deterministic, machine-readable instructions. Step 1 is provisioning. Log into the Meta Developer dashboard and generate a new API key. To keep this credential secure and out of your application logic, export it directly to your terminal environment as Model API key. Next, initialize a fresh Node.js project using your standard package manager. Then, install the Express framework to handle our server routing and the OpenAI SDK to communicate with the model. This diagram illustrates the technical architecture of Meta's coding stack. Notice the top layer. Meta Model API is drop-in compatible with the OpenAI SDK. We are deliberately using the OpenAI package to talk to Meta's endpoints. Because Meta adheres to these existing SDK standards, you can plug their frontier models directly into your legacy pipelines without learning a new syntax. Create your main application file and import the Express and OpenAI modules at the top. To route to client, first swap out the base URL to point at api.meta.ai/v1. The SDK will default to looking for an OpenAI key. You must explicitly override this by mapping the API key property to your Model API key environment variable. Now set up an Express post route. This acts as the receiving endpoint for incoming webhook payloads. In a production environment, you would add an HMAC signature verification step right here. This ensures you reject any spoofed events and only process legitimate requests from your provider. With this securely routed endpoints and an authenticated client, you have established the required plumbing. Now we can inject the AI logic. Inside your post route, call the client's completion method and explicitly set the target model string to Muse Spark 1.1. Here is Meta's 6-part prompt structure: outcome, context, constraints, acceptance, permissions, and handoff. This framework forces the reasoning model to output strict JSON. We apply our rules here, setting context to property management and constraining it to valid JSON with no markdown. The dynamic text payload, the actual tenant message from the incoming webhook request, is then injected directly into this rigid prompt framework. Let's test the system. Start your local server and use a terminal to post a mock JSON payload. For this test, we will send a message about a noisy, smoking heater. Here is the terminal output from our request. The model returns flawless JSON, accurately classifying the issue as an HVAC emergency with critical urgency. By applying rigorous prompt engineering and strict constraints, we turn a creative reasoning model into a reliable deterministic function. We have moved from a chaotic text message to an actionable JSON object, relying entirely on standard developer tools and the Meta Model API. The next step is upgrading this text-based webhook into a multimodal diagnostic tool. Because Muse Spark 1.1 features native vision capabilities, developers can allow tenants to attach photos of the damage directly to the webhook for superior AI diagnostics. Integrating Meta's frontier intelligence into standard webhooks equips your software platform to handle unpredictable, real-world problems.